A motorist drives south at 20 meters per second for 3 minutes, then turns west and travels at 25 meters per second for 2 minutes, and finally travels northwest at 3 meters per second for 1 minute. For this 6-minute trip, calculate the total vector displacement, the average speed, and the average velocity. Let the positive x-axis point east. Okay, so let's draw the graphical representation. Okay, the first displacement, so that's the 20 meters per second multiplied with 3 minutes. So that's 3600 meters. So let me show you the solution. So the solution is actually velocity is equivalent to distance over time, and distance is equivalent to velocity times time. So that's centimeters per second multiplied with 3 minutes. Okay, for D2, we have 25 meters per second multiplied with 2 minutes. So that's actually 3000 meters. For D3, that's 30 meters per second for a minute. So that's 1800 meters. Now let's draw our resultant vector taken from the initial position to final position, and that's our resultant vector. So to solve for the resultant vector, we could actually use the component method. using the unit vector form of these three displacements. So that's 3600 j hat, that's negative because it's going south. And then for the second displacement, we have negative 3000 meters I hat, that's going east. I'm going west. And then for the third one, we have 1800, that's cosine 45 degrees j hat minus 1800 sine 45 degrees. Actually, the other one is sine and this one must be cosine because that's I hat. Anyway, they have the same value, so it's not gonna give a wrong answer. So our resultant vector is equivalent to negative 4270 I hat minus 2330 j hat meters per that's meters. Okay, or it could be also written this way. Letter B, for the average speed. So here is our working formula. But before that, we need to compute first the total distance traveled. So that's 8,400 meters or 8.4 kilometers. Next, let's compute the average speed. And here's our working formula. So that's 8,400 meters over total time of 6 minutes. And we need to convert everything that we have to get to meters per second. For the average velocity, we're gonna need to compute for the magnitude of the resultant vector. Using Pythagorean theorem, so the magnitude of the resultant vector is 4.87 kilometers. So that's the one that we're gonna be using to solve for the average velocity. So that's 4,870 meters over the elapsed time of 6 minutes, which is equivalent to 6 times 60 is 3,000. I think it's only 360 seconds. And our average velocity is 13.5 meters per second. Okay, along the direction of the resultant vector. A fish swimming in a horizontal plane has velocity given as 4I hat plus 1G hat meters per second. So that's the initial velocity at a point in the ocean where the position relative to a certain rock is 10I hat minus 4G hat meters. So that's the initial position. Now, after the fish swims with a constant acceleration for 20 seconds, its velocity now, so that's the final velocity, is 20I hat minus 5G hat meters per second. Now we're looking for the components of the acceleration of the fish, the direction of the acceleration, and if the fish maintains constant acceleration, where is it at time is equivalent to 25 seconds, and in what direction is it moving? So we know that the formula for acceleration is equivalent to the change in velocity over change of time. And since this is a two-dimensional acceleration, we have the acceleration on the x-axis, the x component of the acceleration and the y component, which will be solved separately. Okay, so that 20 meters per second was taken from the final velocity, and that minus 4 meters per second was taken from the initial velocity, and the total time travel is 20 seconds. That's for our a sub x, and the answer is 0.8 meters per second. Now let's solve for the y component. So for the y component, that's negative 5 minus 1 meters per second, 1 meter per second. So that's it. The answer is negative 0.3 meters per second squared. Okay, so that's letter A. For letter B, the direction of the acceleration. By the way, it can also be written this way. Now let's solve for the direction using arctan of AY over AX. And our angle is actually equivalent to negative 20.6 degrees. And it's actually located on the fourth quadrant. Okay, and negative 20.6 degrees is not the only direction that you could give for this one. So you could actually have several ways to give the direction. Okay, you could actually get the positive angle, which is equivalent to round it up to 339 degrees. Okay. For letter C, when time is equivalent to 25 seconds, we have here the solution for the change in position given this formula. And we know that the initial position is given as 10 I hat. Okay, so that's 10. The initial velocity, the x component of the initial velocity is 4 meters per second times 25 seconds, right? and the acceleration is 0.8 as we have what we have solved earlier. Then you will have your value for x sub f, is equivalent to 360 meters. Now let's have the y component. So using the same formula and applying the given parameters. And the value of y sub f is equivalent to negative 72.7 meters. Okay. For the final velocity, okay, we're gonna be using this formula and apply the given parameters or whatever we have solved. Okay. So that's 25 seconds. Therefore, we have 24 meters per second for Vx sub f. Okay, for Vy sub f, same formula. No. So our formula would be Vyi plus Ayt. Okay, so that's our formula. And apply the given parameters. Therefore, our the vertical component of our final velocity is equivalent to negative 6.5 meters per second. And the direction is equivalent to arctan of Vyf over Vxf. And our direction is actually equivalent to negative 15.2 degrees. A playground is on the flat roof of a city school, 6 meters high above the street below. The vertical wall of the building is 7 meters high. And that's the 7 meters, forming a 1 meter railing around the playground. So that's the 1 meter railing. A ball has fallen to the street below, and the passerby returns it by launching it at an angle of 53 degrees. So that's the angle, 53 degrees. And the distance is 24 meters from the base of the building. So that's 24 meters. And then the ball takes 2.20 seconds to reach the point vertically above the wall. So the point is over here. Okay. Now find the speed at which the ball was launched, the vertical distance by which the ball clears the wall. Find the horizontal distance from the wall to the point on the roof where the ball lands. Let us now solve letter A. So using this formula, apply the given parameters. And here we can solve the initial velocity as 18.1 meters per second. For letter B, we're going to be using this formula and apply the given parameters. So y sub f is equivalent to 1.13 meters. Sorry, it's not yet 1.13. It should be 8.13 meters first. And then we're going to subtract the 7-meter height of that building. And then we will have y as 1.13 meters. For letter C, we need to solve first the time that it takes to travel to where point X is. Okay, so by solving the y component, we know that the y component is 6 meters. Okay, so by using this formula and applying the parameters, we're gonna get the time, okay, for it to be 6 meters high. And since it's a quadratic equation, we have two values for time, which are 2.45 seconds and 0.49 or 0.5 seconds. Now, we know that we're going to be using 2.45 because um, there are actually two scenarios wherein the height of the ball is 6 meters, but we're gonna be using the one that came after the first one. Okay, so we're gonna be using 2.45 seconds to substitute to the equation given as, to solve for x of f, we have x of f is equal to xi. Therefore, there we go. Okay, and apply the given parameters. And our xf is actually equivalent to 26.69 meters. Okay, but that is not yet the final answer. We still need to subtract that 24 meters from 26.69 meters. Therefore, the value of x is equivalent to 2.69 meters. Thank you for listening and watching this video. Okay, tune in with more videos. Have a good time. Bye.